So, here's how you do it. We write x over here, we write negative 1/2 x plus 2 in the middle, and then we write the y over here. Okay, because I have 1/2 right here, the easiest value always, every single time without fail to plug in, is 0. So always plug in a 0. I'm intentionally writing the 0 down because I'm going to write another number up here. What number can I multiply negative 1/2 by to end up with a whole number? Like 1/2 times what is the whole number? 2, right? So I'm going to use negative 2 and positive 2. So all that you do is you think about this denominator when you have a fraction, and that's what the term goes here and here. I just look at the denominator, match it up with these numbers, right? This one was negative as well. And then I'm going to end up with whole numbers, because whole numbers are a whole lot easier to graph. So I'm just going to plug in over here, negative 1/2 times negative 2 plus 2. Then I'm going to do negative 1/2. And again. So this one I'm plugging in 0, this one I'm plugging in negative 2. Positive 2. Right? I just looked at this denominator. That determines what goes over here. That's it.
You always
You could have more if you want. You need at least 3 though. Yeah, if it's a fraction. Otherwise, so if I don't have a fraction here, I'm always going to choose negative 1, 0, and 1. Okay, Riley? Yeah, that's a really good question. I definitely would still, I want 1 negative value and 1 positive value and 0. Okay? Good question. Alright, so if I'm multiplying negative 1/2 times negative 2, I've got negative 1 over 2 times negative 2. I can put that over what? 1. So what do I get when I multiply that? You don't cross multiply. You multiply. I would write it. Multiply straight across, top and bottom. Okay? So what's negative 1 times negative 2? Positive 2. And 2 times 1 on the bottom? 2. So what's that equal? 1. So when I multiply over here, so to multiply fractions, I'm going to write that down too. Multiply fractions straight across, top and bottom. Okay, that's how you multiply fractions. So we got what when we multiply this right here? We got positive 1 plus 2, which is what? 3. So if you need to show a little work down here because it confuses you a little bit, you can, you don't have to. So negative 1/2 times 0 is 0. 0 plus 2 is 2. Okay, negative 1/2 times 2, we can do that off to the side as well. Negative 1/2 times 2 over 1. So what do I get when I multiply the top?
negative 2.
I get negative 2, and then 2 times 1 is, so negative 2 over 2, which equals what? Negative 1. So down here I get negative 1 plus 2. What's negative 1 plus 2? 1. There's a commutative property in addition Or you can just think of this like 2 minus 1 as well. Sometimes that's easier to think about. So I have 3 points that I can graph now. I have -2, 3, I have 0, 2, and I have 2, 1. So we're going to graph it next. So the points I had were -2, comma 3, and then I have 0, comma 2, and I have +2, comma 1. So because the y values go down by the same amount each time, this graph is going to be in what shape? Straight line, right? But the difference between the y values is the same each time. So that first difference is the same, which means that it's going to be a line. So let's graph it. The calibration's a little off. I'm going to calibrate real quick. It's annoying when you graph and it's slightly off. Okay, so we're going to graph this. So we have a point at -2 on x, +3. We have a point at 0, 2, and we have a point at 2, 1. 2, 1. Okay, that's why you graphed 3 points. Like I messed up, right? And I graphed one right here, and I saw it wasn't going to be a straight line, so I'm like, oops, take that away. And then I'm going to draw my line in. Okay, bam, done. So graphing a function rule, we make the XY table, figure out some values to graph, some ordered pairs, right? That's what these are called, ordered pairs. And then we graph. Who wants graph paper for the next one? Because we're going to graph 3 or 4 of them. Let me just pause this real quick. We're going to graph it. Okay, you want to write this function down? Write that function down. We're renting a truck 8 hours. That's also important. And we want to write draw a reasonable graph of the function, given that the daily limit is 12 hours. So I'd write that kind of key information down, and then we're going to make, in this case, it's not an XY table, because we're using 8 per hour. And then we have the cost over here. So we're going to graph a couple of points to figure out what this graph's going to look like. Can you have negative numbers given this situation? No. Because it's not like you're going to walk up and give the guy money and then not get a truck in return, right? That'd be kind of dumb. Yeah, right. He would give you money, right? And that's not a good business. He wouldn't be in business very long. So what's the easiest number always, every single time to graph? Easier than 2 or 1, 0. So let's plug in 0. Now, it's hard to graph decimals, so what should the next number be? 2. Good. Because if I do 1, then I'm going to have decimals to graph, and that's kind of annoying. So we could graph 0, 2, 4. If I go by 2s, it's going to get rid of this decimal, right? And then let's graph 12. because they talked about 12 in the problem up here. So if I plug in 0, I have 12.5 times 0 plus 30. I have 12.5 times 2 plus 30. 12.5 times 4 plus 30. And I have 12.5 times 12 plus 30. So I'll give you a sec to write that down. So writing this down. All you need to show is the first quadrant. You guys know about quadrants? You should have learned it last year. So if we talk about quadrants, where's quadrant 1? Right there doesn't mean anything. Top left? Top right. This is good information for you to have, sure. We're going to figure out the C values over here, and this is quadrant 4. So when we're talking about a real-life money-changing hand kind of scenario like we are here, we're only going to be in quadrant 1. Because if you get in the negative area, you're losing money, and that's not a good business, right? So all we're going to do is show quadrant 1 when you graph this. All right, let's figure out these values. So 12.5 times 0, Menfrey. 0 plus 30 is 30. 12.5 times 2 is what, Bren? 25 plus 30? Excellent. 12.5 times 2 is 25. What's 12.5 times 4? 50 plus 30 is 80. And this one, 12.5 times 12 plus 30 is 180. Okay, so get those down. Yep. Exactly. Right? We know that it's going to be just an X, or in this case H, because these values, the first difference is, well, not this one, right? But 25, because we skipped numbers. Alright? So we're going to graph this. We've got 0, 30, 255. So I'm going to write these ordered pairs down here. 0, 30, 2, 55, 3, 4, thank you. Hard to remember them all. 480, and then it was 12, 180, right? Okay, so let's graph this. We're only going to show that first quadrant. So the first ones are on the x-axis, the second ones are on the y-axis. So what's a good thing to go up by on the x-axis? 2, right? I've got plenty of room to go by 2s here. So we could go up by 2. 2, 4, 6, 8, 10, 12. And then how about the y-axis? 20s, I agree. 20 is a good thing to go up by, so we'll go 20, 40, 60, 80, 100, 120, 140, 160, 180. So if we at 0 on the x, we get 30 on the y. At 2 on the x, we get 55. At 4 on the x, we get 80. And at 12 on the x, we get 180. And we know this thing's going to be a straight line, so If you graph it and your points are not on a straight line, that's your clue that you did something wrong. So we're going to draw the line in. So there's your line. So this graph is what's called continuous. So this example, we're going to talk about continuous graphs, meaning can I run a truck for 5 hours? Right? I can run a truck for 5 hours, and if I do, my cost is going to be $90. Can I rent it for like 5.5 hours? Absolutely. And they'll charge you for the increments of hours if you rent trucks. Like I've moved a couple of times I've moved a ton of times in my life, but I've rented a lot of the U-Haul trucks, and they'll charge you down to like 15-minute increments. Okay? So that's why it's a continuous line. It's not a series of dots. It's continuous. Okay? So continuous means the graph's going to be a line. So the good thing to write in a different color. Right? And the reason it's going to be a line is we can graph little feet. We can rent a truck for parts of an hour. The next example we're going to do is what's called discrete. And you'll see why that is. I'm just waiting for people to finish writing that down. Definitely. All right, let's look at this next example. Are we good? Anyone need more time?
Nope.
If you need another, Sydney will hand you one. All right, so here's what you want to write down. Don't write the whole thing down. You don't need to. So we're buying eggs, and they're $1.75 per carton. So we're going to determine if it's continuous or discrete. So if you go to the grocery store, we're going to, discrete means that the graphs can end up as dots. The reason this one is discrete is because you can't buy like 2/3 of a carton when you go to the grocery store. Right? You can't come in there with your scissors and like cut through the cardboard thing and be like, here, this is how many I want. So you'd be like, well, we're charging you for 12. So you can buy half cartons, but this doesn't talk about that. So you can't buy like 5 eggs. You can only buy 12 at a time. Okay? Because you can't buy parts of a carton. I know. It's okay. We're going to graph this stuff. It's all good. All right. Yeah, no. All good. All right. So we are going to do C for carton. Or that's not good. Let's use X and Y. We'll call X carton. And Y is going to be the cost. Okay? So we're going to make our XY table. So what's the easiest number to plug in? Always, always, always? 0. So it's going to help us on the graph, right? You're not going to go in and buy 0 cartons. Yeah, I guess you could. Besides, you don't want eggs. Let's do 0, 1, 2, and 3. Well, you go up by 4s, but you could. You're just going to graph it, and as long as I see the dots in the right place, technically it doesn't really matter what you go up by. So 175 times 0 is what, Ellie? 0. And then 175 times 1 is what, Annabelle? Yeah, 175. And then what's 175 times 2? Anyone? Times, what is it? Times 2? 350. So what we're doing is we're adding 175 each time, right? So now we have 175 times 3. Excellent. $5.25. And now we're going to graph this. So this is discrete. This graph is discrete. You're going to have to tell in your homework whether it's discrete or continuous for some problems. It's discrete because you can't buy part of cartons. So, yep, exactly. Graph will be a series of dots. Yeah, it's basically, except the dots will form a line, you know, but you don't connect the dots with the discrete graph. Correct, you can't. Your quiz, we'll talk about it as soon as we're done with the next 2 problems. Okay? Alright, so here we go. Ready? Okay, go. Yep. Can you stop, please? You're like that. You are. Can you stop, please? Put it down real quick. You're annoying, right? It's super annoying. Like that. Okay, we good? Alright, let's graph it. You can look on to your neighbor, right? If you didn't finish writing it. So what goes down the x-axis? We went, right, so 0, 1, 2, 3. And then how about on the y-axis? What should we go up by? How about 0.5? We'll go by 1, but technically, because I'm going to go by 2, so it'll be by 0.5. That makes sense. Right, because that would be 0.5, that's 1. So what were our order pairs? We had 0, 0, 1, 175, 2, 350, 3 was 5.25. We're just going to graph those. So we're going to go 0, 0. And then we've got 1.75. Right there. 2, 3.5. Which is right here. And then 3, 5.25. A little bit above there. So don't make a line, don't connect the dots, right? Because this is discrete. You can't buy part of a carton of eggs. So that's why we're not connecting the dots. You're speaking so quietly. Yeah. You can go half a carton. So we could add a point in the middle of all these too, right? But that's not what the story problem said. It only said per carton, so I'd mark points out if you did that. Even though in reality you can't. Got to go with the story problem. Okay, so you need time on that? It is in a line, but don't connect the dots on discrete graph. You just have to know by reading the problem, you can't buy like parts of cartons of eggs, right? Okay, Riley and then Emma. Does it feel like they have? Colin complains. Emma? On that last problem, don't connect. This one, yes. Only in those scenarios where you can't do parts of things. Like you go to airport and you pay for parking, you pay per day. Right?
You don't pay per like minutes.
Yeah, they don't break it down to little tiny increments. Okay, so we're going to graph this one now. Example number 4, x squared minus 1. Making the x-y table. Okay, so when we graph x squared, it's going to look like a U. It could also look like an upside down U if it's negative x squared, but essentially it looks like a U, right side up or upside down. So when we have these kind of graphs, we want to graph a negative number, 0, and a positive number. If you want to graph 5 points, because it will honestly make it a little bit easier to graph, you can do that, but you don't have to. Yep?
So you do the same thing.
Yeah. Yeah. Okay, so we're going to have, I can talk over you, don't worry.
Sorry, last year my teacher would yell at me if I tried to
That's fine. I'm loud enough, it doesn't matter. It is true. Okay, so we're plugging in -1 into this function right here. So get that down. The next graph we're going to do is going to be absolute value. When you graph that, it looks like a V. So here, -1 squared is what? -1 times -1 is 1. 1 minus 1 is 0. 0 squared is minus 1. -1. 1 squared, 1. 1 minus 1, 0. Yes, it is the pattern, right? It goes down 1 and then back up 1. That's what makes that U shape in the graph. So we have -1, 0, and 1. I'm going to write these ordered pairs down again. And we got 0, -1, and 0 when we did those. And now I'm going to graph it. So the points are going to look like you can make a V, but you need to, as best you can, try to make it look like a U. So we're going to graph these points now. I have -1 on the x, 0 on the y. I have 0 on the x, -1 on the y. And I have 1 on the x and 0 on the y. So when I draw this, you could make that look like a V, right? Because the points are all really close together. But you need to do your best to make it look like a U. And on tests, when I get a lot of kids that will do this, because sometimes when they draw it, it doesn't look like a U. They're literally right. Looks like a U. If it looks like a V and I can't tell, I'll mark it wrong.
What if we write looks like
Heck yeah. If you're right, looks like a U, then I'm going to give you full points, because you know the graph of x squared looks like a U. Okay? Yeah, so that's why I write, looks like a U. Because the U1 is x squared, and the absolute value, you'll see the absolute value bars. Okay, let's graph an absolute value one. Last example. So this is for B, and we'll graph absolute value of x plus 3. So we're going to again make our xy table. Not when you're just plugging in values. So again, I'm going to choose -1, 0, and +1. And just plug it in. So I have absolute value, -1, plus 3. Absolute value, 0, plus 3. Absolute value of 1, plus 3. You always, when you have absolute value or x squared, you always want to graph a -0 and a positive number. And then if you have a fraction in front of it, then whatever the denominator is, you choose that for the negative and positive number. Right? So if we had 1/3 in front, we choose -3, 0, and 3. Okay? So, absolute value of -1 is what, Jordan? Absolute value of -1. No? Absolute value always makes the number positive. So absolute value of -1 is 1. 1 plus 3 is 4. Jordan was answering.
What?
Absolute value, Brian, absolute value of 0 is
0.
plus 3.
3.
What do you think this number is going to be?
2.
No? It's a B. No? What? 4. So absolute value of 1 is 1. Absolute value is always positive. We should write that down. Because hold on, let me write this down. Absolute value is always positive. Question, Connor, and then Cedric. Yep. Absolute value of -10 is 10. Cedric, question? Yes, exactly. Okay, let's graph this thing. They're actually bigger than 8.5 by 11. So when they put them in their notebooks, then it sticks out and it's annoying. That's why you don't do it. Alright, so when we plugged in -1, what did we get? And we plugged in 0, we got? Plug in +1, we get 4. Okay. So we plug in -1, we get 1, 2, 3, 4. We plug in 0, we get 3. And we plug in 1, we get 4. So because this is the absolute value of x plus 3, it's going to look like a V. Absolute value looks like a V. Most of you don't have problem making it look like a V, right? It's more the U's can sometimes look like a V. So you just draw it like that. X squared.
So absolute value is always B.
V.
Okay.
And x squared is always
B.
U. X squared is a U, absolute value is a V. That's all right. You got notes down. So your homework's on the board. Page 257, 9 through 31 odd. Make sure you get that down. It's going to be, it's not yet, but it's going to be.